That brings us to the final section of the presentation. How do we save lives? So we took the existing pilot, the approach, and we extended that. Now, for this purpose, we needed even more high resolution images. So earlier I mentioned we used moderate resolution. Now we went down to 50 centimeter by 50 centimeter resolution. So these are the three steps. Once you get the satellite images for a given location, for a particular city, then we start detecting the buildings. We identify the building footprint, and from what you see on the left to the right, I'll talk a little bit more on this. And then once we detect the buildings, second thing is detecting the greenery, places where people are not likely to be in big numbers. And then we combine these with a gridded population data at a 1 kilometer level to identify the population for each of those microgrids, the 100 meter square level. So here's how these three steps work. First, we have the picture, and we trained a deep learning model which is able to identify the contours, estimate the area, count the number of buildings. So that's the current work. And then step two is detecting the hidden features, which is like the greenery and other water bodies. Let us say you have a picture like this on the left-hand side. From this, we can detect the green cover, which is what is extracted and shown there. Water cover, you can see the water bodies, and the land cover. And when you combine these, you get an image like this. So we add the building footprints, which is going to be an indicator of population density. And we subtract some of those greeneries because there the population is likely to be less. When we combine all of this, then we bring it into the third step, which is using the gridded population of the world, GPW data, and all of these other inputs to come up with, down to a grid level, what is the population for each grid, high to low. And here's an example. So this is the actual input satellite image, 50 centimeter resolution. You have the housings you can see, and then there is a stadium. And when this is passed to the model comes up with an output like this. So it identifies those grids. The blue ones are the high population ones, and orange is the low population one. So you don't want to be releasing mosquitoes in the stadium. People may not like it. So this is how it is able to estimate to a fairly good level of accuracy. And then when you zoom out, you go down to the city level, and now you have this, the model rolling all of these details up one level. And this is what the grids look like, tinier. And you still have those blue and the orange shaded ones with the population. And finally, the last leg was just optimizing and picking those specific localities, named localities. So here's how the full solution works. It all comes together. Now, first, the WMP team, they choose a country and a city. Say, okay, they're going to implement this, for example, and say Orlando in Florida. And the question is, where should we release? What all communities within Florida, within Orlando, should we release this? So that input of the city name is given to the solution, and it picks all of the data, extracts the images, and then it runs the model, which automatically extracts the building footprints, and then it combines and does the population estimation. So we come up with what we have seen, those grids with those squares. The last the last item needed for the decision making is, what percentage of population do I want to cover? If I want to, in phase one, if I want to cover 50% of the population, so that I estimate that based on the number of mosquitoes I'm able to rear. So if it is 50%, we find out what area should be covered. So for example, 50% might be 20% of area, whereas to go to 80%, I might have to increase this to 60% of coverage. So they can choose, and that's where I mentioned it is an optimization problem. We can choose what is the right level based on the number of people we want to reach out to. So this is how the solution works, and they use this for site planning decisions. What's the outcome? Earlier, I mentioned about the manual process. That used to take almost 3 weeks for people to manually collect the data, GIS experts to work on it and prepare all of it. And that has been reduced to just 2 hours. So over 99% savings in time. Not just the time savings, but also effectiveness. So earlier it was slightly old satellite images, not very accurate estimation. Now we have up-to-date, high-resolution satellite images like 50 centimeter square level. And this is the model is able to come up with the population estimates far more accurately. We found out in our tests. And the efficiency overall, even after you release the first set of mosquitoes, the post-release monitoring and validation, it has to be done periodically. It's very, very efficient. You can do it multiple times. And there are some of those activities which can be done real time as well. So this solution now is being rolled out across several countries. And Microsoft and World Mosquito Program have made some press releases, and there are some major plans being chalked out. And this is something which we are very excited about. The project has gone live.